Hello again. To further continue, after understanding the nomenclature, we are going to see the exact working of diagnostics trouble code. I request all of you to pay a lot of attention to this particular lesson because this is very important in as far as onboard diagnostics and vehicle diagnostics is concerned. This is a very important lesson. So diagnostic trouble code is a crucial component of modern vehicle board diagnostic system. It serves as vehicle's black box, storing information about malfunctions and irregularities detected by various sensors and central modules throughout the vehicle. Okay, so this serves as the vehicle's black box. All right, so how DTC memory works? Detection of malfunctions. The process begins when vehicles, various electronic control units monitor systems using sensors. So these electronic control systems, they monitor the system using sensors, and various ECUs like engine control module, it monitors the engine performance. Transmission control module monitors the gear shifting. Anti-lock braking system module monitors the wheel speeds, and likewise many others. And each system has predefined parameters for normal operation. And when readings fall outside these parameters, the system first checks if the regularity is consistent, not just a momentary glitch. Okay, so first of all, before a DTC, before the vehicle detects or confirms that it is detected, the system first checks if the irregularity is consistent, not a momentary glitch. It then determines the issue effects on emissions, drivability, and safety. Okay, I have mentioned three systems here: engine, transmission, and anti-lock braking, which are corresponding to emissions, drivability, and safety. When it comes to DTC generation, when a fault is confirmed, the ECU generates a specific DTC following standardized formats, and the code is stored in non-volatile memory. What is meant by non-volatile memory? It won't erase when the power is off. This is important. Even if the vehicle is shut off, the memory the non-volatile memory will not allow the code to be wiped out of the memory. The ECU may illuminate the malfunction indicator lamp if required. Now, DTC storage formats. DTCs are stored with additional information which comprise of freeze frame data, a snapshot of the vehicle's conditions when the fault occurred, speed, RPM, temperature, etc. Next is status information, whether the code is current or historic, confirmed or pending. Now, when it comes to maturity counter, how many drive cycles the fault has been detected. And when it comes to mill status, whether the check engine light was commanded on or off. So these are the various other informations which are stored along with the DTCs. And types of DTCs in the memory, they represent currently existing faults. First is the current active code. Okay, so of the various types of the diagnostic trouble code, the first code is current active code. It represents currently existing faults, may illuminate the mal indicator lamp, the malfunction indicator lamp, and it requires immediate attention for emissions related issues. When it comes to pending codes detected in one driving cycle but not yet confirmed. All right. So, and pending code does not illuminate the MIL. This is the important salient feature of the pending code, and it will become current if detected again in the next cycle. Okay, understand this very carefully. It become current. It gets upgraded from pending code to current code if it is detected in the next cycle, in the consecutive cycle. Now, historic codes, these are called inactive codes, and the past faults that are no longer present. Useful for intermittent issue diagnosis, typically stored for 40 to 88 warm-up cycles. Okay. Now coming to permanent codes, special codes that cannot be cleared by normal scan codes, required by OBD regulations for emission related faults, and only erased after specific repair and monitoring conditions are met. So these permanent codes can be erased only after some major repair and after some monitoring conditions are met. Okay. Now, when it comes to DTC memory management, storage allocation, modern vehicles allocate specific memory sections for different modules. All right. In the DTC memory, the storage allocation is a very important vertical or an important slot. And high-end vehicles may store hundreds of codes with detailed freeze frame data. What is meant by freeze frame data? I will let you know. And memory is typically organized by system priority. Memory, what is meant by memory clearing? This is again the important vertical of the memory management. And it can be cleared manually with scan tools. Some systems automatically clear codes after a set number of fault-free cycles, and permanent codes require specific conditions to be cleared. Okay, now third one, the memory protection. Critical codes may have write once memory. Some systems maintain separate backup copies of important codes, and also event logs may track when codes were set and cleared. So when it comes to memory management, first vertical is storage allocation, next is memory clearing, and next is memory protection. Now, how do you implement this memory management? What is the technical implementation? The memory types used are, first is EEPROM, electronically erasable programmable read-only memory. This is the most common type of memory that is used in diagnostics. Next is flash memory, used in newer vehicles for higher capacity. Next is NVRAM, non-volatile RAM for temporary storage. Now, when it comes to data structures, typically organized in tables with code, timestamp, and status fields. It may also include linked lists for dynamic memory allocation in advanced systems, and often includes checksums to verify the data integrity. Okay, so this data structure is one of the important way through which the technical implementation is accomplished. And memory mapping, each ECU typically has its own DTC memory section. Gateway modules may consolidate codes from multiple systems. Memory addresses are standardized within memory specifications. All right, so to continue further, there is something called diagnostic access to DTC memories. And this diagnostic happens to DTC memories through some standardized protocols like SAE J1979. It defines the standard modes for DTC access. Mode $03 request store DTCs. Mode $07 request pending DTCs. And mode $08 request permanent DTCs. So these are the various modes in which the various types of DTCs which I previously mentioned are pulled out or commanded to come out. All right. Next comes the enhanced diagnostics. Manufacturer specific protocols access additional memory details. Some systems allow historical trend analysis of fault occurrences, and advanced tools can access raw memory dumps in some cases. All right. So some advanced tools they can access even raw memory also. Now, what are the practical implications of DTC memory? The first implication is repair diagnostics. Technicians use DTC memory as starting point for diagnostics. Freeze frame data helps recreate fault conditions, and code history shows intermittent or developing problems. Okay, so these are the important implication of the repair diagnostic. You repair the diagnostics through the DTC memory, or freeze frame help to create the fault conditions. I mean, what are the various conditions that were prevailing when actual problem occurred? That is called freeze frame data. For example, at what RPM, at what is the temperature, what is the water temperature, what is the peak cylinder temperature, what is the peak cylinder pressure. Freeze frame data comprises of all this data when the diagnostic trouble code is detected. Now, when it comes to emissions testing, DTC memory is checked using during inspections. Presence of emissions related codes causes immediate test failure. Readiness monitors must be complete. for valid testing. Now, when it comes to vehicle maintenance, in vehicle maintenance also there is a practical application of DTC memory. Predictive maintenance uses this code trends. So depending upon the code trends, only predictive maintenance is completed. And also fleet management systems monitor DTC memory remotely. And also lease warranty evaluations may check code history. Okay, so even when the warranty issues are coming, checking the code history is a common practice. Now, there are some advanced DTC memory features in modern vehicles. For example, extended data logging. Some systems store waveform data around the fault events so that the fault events can be extrapolated. It may include multiple pre and post fault data points, allows engineers to allow fault progression. Okay, so it allows engineers to analyze the fault progression. Next is the cloud integration. Telematic system upload DTC memory automatically. It enables remote diagnostics and predictive maintenance and creates centralized vehicle health histories. Okay, so cloud integration is a very important advanced DTC memory feature. And last but not the least, AI assistant diagnostics. So machine learning analyzes the code patterns across the vehicle populations. Okay, so in future, instead of just understanding the code pattern in only one vehicle, with the help of machine learning, you can even analyze the code pattern across the vehicle population. And this is a very important application as far as the fleet management is concerned. It can predict likely root causes based on code combination, suggests repair procedures based on historic data. Okay, so these are the various advanced DTC memory features in modern vehicles. So to conclude, DTC memory represents sophisticated fault recording system. So understand this, it is a fault recording system that has evolved from simple code storage to comprehensive vehicle health monitoring. Its proper understanding and utilization are essential for accurate vehicle diagnostics and repair in modern automotive technology. Okay, so I hope all of you understand the importance and the pivotal role of DTC memory in understanding the problems in the modern vehicles. Thank you.